Hello everybody, welcome to Drawing Shapes. This is really the video where we really start doing some programming and understanding how to tell a computer what to do. So pretty exciting. We finally get some power over the computer at this level of the code. So the objective for this video is going to be, well, obviously drawing shapes on the canvas that P5 draws things on. But more than that, understanding this idea of how we give instructions to a computer and this whole question of how you get it exactly right so that the computer knows what you're talking about, okay? In the video version of this, I'm going to play it a bit looser, and I'm going to just try and get you to the point where you're able to type in instructions to the computer and see that you're getting some of the results that you want to get. So let's see how that goes. All right, so let's go back to not seeing my face, which might be a relief for everybody. So as I've been saying, every time we want to start working on writing some code, we need to have our template project downloaded. And one thing that I'm going to recommend is that for each week, when you're going through the lecture material, you're going to want to follow along. And so a sensible thing to do would be to have kind of a project for that week. Yeah? So you'll have a template project for that week, and you can kind of just throw code into it, delete stuff, add stuff to try things out as they get introduced in the videos. So the first thing that we're going to do is we're going to go back over to our browser. We're going to go to github.com/ you know where I'm going, right? The course homepage, github.com/pippinbar/cart253-2020. Probably worth bookmarking. I'm going to go there, and I'm going to go to, on this very first page, the templates folder. Templates folder, I click on that. Template p5project.zip, I click on that. And then in this weird kind of blank looking page, I click on this little download button here to download the project. Click. It gets downloaded, and either you know where your files get downloaded to, in which case just go there, or you can usually in the browser get it to tell you to show you in the Finder or the File Explorer or whatever it's called on your system. And my one will have ended up in my Downloads folder. Once again, I'm going to copy this just for the moment onto my desktop, just because I find that to be a little bit tidier. Desktop. And then I'm going to unzip it by double-clicking on it. So I've double-clicked on the zip file, and it's given me the classic template P5 project folder. Now, because I actually have an intention this time with the kind of code I'm writing, I'm actually going to rename it. I'm going to call this folder, and I'm going to hit return on my Mac to rename the folder. I'm going to call it Drawing Experiments. Okay, there we go. So now the folder has been renamed. Now, one thing that you could do if you want to is you could store these experimental folders, one for each week, might be a good way of doing things. You could put them into your GitHub repository, right? And that way you could kind of store them along with everything else and keep track of your work. You don't have to do that, but it's a chance to practice using GitHub. So I'm going to quickly include this folder in my GitHub repository. Now to do that, we need to copy the folder or move the folder across into the GitHub repository itself. So I'm going to bring up another window on my Mac. There we go. Certainly hope there's nothing compromising there in my recent files. I should change that. And I'm going to go to the location of my GitHub folder, which is in Documents, and then GitHub, and then there it is there, right? Cart253 is my repository that I created for this course. So I click on that as well. I can see I've got a project 1 folder that I put there as an example. That has nothing in it. I'm going to delete that right now because I don't need it. But I am going to create a new folder inside my Cart253 folder called Experiments. Okay? And then, in order to have my drawing experiments work be recognized in my repository, I'm going to drag it from the desktop, which is where it is over there, and I'm going to put it into this Experiments folder. Just like that. So it just moved across. All right. So now I've got my repository folder, Cart253, Inside that, I've got a folder called experiments, and inside that, I've got that folder that I renamed from the template P5 project folder to drawing experiments, and that's now sitting in that folder. Okay, so that's there. And indeed, if I were to go to GitHub Desktop now, I did Command Space, and then I type in GitHub Desktop and hit return. You can see that there's lots of changes in my cart253 repository, right? So the current repository is cart253, and there's 11 changes. Those 11 changes reflect the 11 files that are part of the template project. And you can see this little plus sign saying that I've just added all 11 files on here. So I've got clown.png, got readme.md, another one, bark.wav, etc., etc., etc. So that's all of the files that I just added. I'm going to say that I'm going to commit these to the project, even though I haven't done any work. It's usually a good idea when you start a new project to commit just right at the beginning to say that you've started. So started drawing experiments project. It's not really a project, is it? But that'll do. So I've given my little message, and I'm going to commit. Good. And I could push now, or I could push later. I'm going to push later, so I'm just going to let it sit there. It's not going to be uploaded to the website yet, but it is committed inside my local repository. That's why we can see that there are 0 changes. Okay, so that's my work done with GitHub Desktop. I'm going to hide this window, Command H on a Mac. And the next thing that I want to do is I need to open my project in Atom, right? So to do so, I am going to open Atom by typing in Atom. You can open it however you like. And I'm going to go to File, Open, to open the project. And then I'm going to go to the location of that folder, right? So Documents, GitHub, cart253, Experiments, Drawing Experiments, which is the folder that contains the project. So remember, I'm opening the folder that has the project files for this project. So the way to tell is it's the folder that contains index.html as well as these other folders, right? That's the thing I want to open in Atom. So I've got that selected, I click Open. Et voila, I have my project open. You can see at the top it says Drawing Experiments, and then it has the correct files beneath. Now, because now what we're going to be doing is we're going to be programming, we are going to exclusively work inside the JS folder for JavaScript and inside the script.js file, okay? And for the purposes of today, again, we're just going to work inside this setup function, okay? So we're going to write our code inside these curly brackets, the opening one and the closing one. We're going to write our code right here. There, okay? So that's where I'm going to start typing stuff in so that we can test out this idea of drawing shapes. Great. So before we really get into drawing stuff, we need to know about this thing called the canvas, okay? The canvas is the thing that P5 draws things on, okay? And to be able to see it, I showed this in a previous video, but let's do it again. I'll just draw a background command. So here is in setup background, and then inside these parentheses 200, 200, 200. That's the RGB values that I'm going to use. So again, whenever I'm working in code, whenever I write some code, I save it. I used Command S to save, Control S on Windows, and I go to Packages, Live Server, Start Server. That takes me across to Chrome, and now we can see the canvas, okay? That background instruction that I wrote just now sets the background color. It paints the background color of the canvas that we have to draw on to a gray color. That's what 200, 200, 200 means. And so we can see the canvas, right? This thing here is the canvas. And the canvas itself is an HTML element. So it's something that's included in how HTML works in web browsers. It's a specific thing that lets you draw stuff instead of including text and images in the more standard way that you do in HTML. The most important thing that I really want to talk about with the canvas, though, is just that it's basically just a grid of pixels, right? There's a whole bunch of pixels inside this square because this is a computer screen, and that's how computer screens display things. And indeed, we can think of it like this, okay? This would be a very, very small canvas. It's only 10 by 10 pixels, as you can see from these little boxes. Each of these little boxes is a pixel, and we know that the way that computer screens work is that you change the color of a pixel to some other color, and that's how you represent things on a screen. The most important thing that we need to be able to do is we need to be able to, in order to be able to draw shapes, we've got to be able to say where we want to draw things, right? We need to be able to specify locations. If we were drawing something in an application like Photoshop or some other drawing application, the way that we specify locations is we just kind of point to them with our mouse cursor and they say there, which is much more intuitive and natural, obviously. But when we're programming, of course, we don't have something where we can just point. We have to be able to write in text and numbers where we want to do things. So hopefully it's not too surprising that the way that we specify locations is with coordinates, right? So the way that we should imagine our screen working is that it has numbers for every column of pixels and every row of pixels. And it looks like this, right? So X runs horizontally from left to right. The very first pixel on the far left is numbered 0, and then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, up to however wide your canvas is. So X is horizontal, and it starts on the left. The one very slightly confusing thing with a lot of programming environments is that Y, the vertical axis, starts at the top and goes down. So the 0, the very first pixel on the Y axis, is actually at the top. And then you get 1, 2, 3, 4, 5, 6, 7, 8, 9, counting downwards for however high your canvas is. Okay? That's really the only thing that you need to maybe spend a moment to remember, is just that the y-axis starts at the top of the canvas, not at the bottom, like we're used to with math. Okay? So, given that, you can probably imagine how you would specify a particular pixel now, right? If, for example, I'm pointing at this pixel here, I've got my mouse cursor inside it. If I wanted to refer to that pixel, I need to give its coordinates. So, traditionally, when we give coordinates, we give the x coordinate first and then the y coordinate. So this would be at 4, because you can see that it's in the column labeled 4. That actually means that it's 5 pixels from the left, right? Because we started at 0. And it's also 4 down on the y-axis. So it would be 4, 4. That would be the location. 4, 4. Likewise, if I pick this pixel, we can see that it's at 6, 8. Because it's at 6. It's on the 6 pixel here, and it's in the 8 pixel here. So 6, 8. This one is 9, 9. The one at the very top left is 0, 0. The next one to the right is 1, 0. The next one below is 0, 1, and so forth. And that's how we specify locations on the screen. It's not that important to really deeply intellectually understand it. You just get used to it because you're going to be using that idea all the time. Okay? That's just the briefest introduction that I wanted to give to the coordinate system. Just remember, you specify locations on the screen by their x, y coordinates. Okay. That's something you will get used to very, very fast. So, here is our canvas that we are running from our code over in Atom. It's gray. We want to start drawing shapes. To draw shapes, we need to write what are called instructions in our code. Okay? We've already written one instruction. If I switch back to Atom, this background thing here, this is an instruction. We're going to talk more about background in a separate video. So we want to add a new instruction to draw a shape. And the simplest shape that we can draw is a single pixel, which in P5 is called a point. So to draw a single point on the screen, we write point, like that, P-O-I-N-T. And then the way that this works in programming is when we're going to give one of these kind of instructions, which is actually called a function call. So point is a function, and we'll talk more about that in a minute. We have parentheses, and then we tell it the information it needs to know to do its job. So inside these parentheses, what are we going to tell this point function in order for it to draw a single pixel on our screen? The main piece of information it needs, the only piece of information it needs, is where should it draw that pixel. So we can draw it anywhere. Let's draw it at 5, 2, because I happen to know that that's what we draw it at in the slides. So 0.52. So we're saying draw a pixel at the location 5 on the x-axis, 2 on the y-axis. And if I save this with Command S, and we go back to our browser, hard to see because it's so small, but there is a little black pixel sitting at the location 5,2 here in the canvas. So we drew the pixel. If I specify different numbers in there, so I go back to atom, and I, for instance, maybe I put it at 50, 50, which is further to the right and further down as well. Remember that as the Y number goes up, you actually go downwards on the screen. If I save that and go back, now my pixel is right in the middle of the canvas. It's at position 50, 50. In fact, that tells us that the canvas is 100 pixels by 100 pixels, at least eyeballing it, right? What if I were to draw the pixel somewhere even further along? So what if I went back and I drew it at 500, 500? I'll save that. We go back and the pixel is not there, okay? Can't see it. So it is possible to draw something that you can't see. The reason that we can't see it is because the point 500, 500 that I drew it at is not inside the canvas. The point 500, 500 is probably, I don't know, somewhere about here, if I'm where I'm wiggling my cursor. And because that's not inside the canvas, we just don't see the point. It is an open question as to whether that point really exists or not. It's an interesting thing to think about. Okay, now, this is really the very first instruction in our programming experience that I want to just go into a bit of depth on. Just quickly, there's not a ton to explain here, and I think you probably already get the point. However, let's just look at it piece by piece, okay? So this line here is an instruction to the computer to do something. We know what the instruction means. That's to draw a point at position 500, 500. Let's change that back to 50, 50, just so it's actually visible. Saving there. And what this is actually called is a function call. So a function in programming is some part of code, might be many, many lines of code, might be a few, but it's hidden from us, so we don't actually see the code that it uses. We just see the name that we need to use it. Okay, so this is called a function call. And the pieces of this are as follows. The first thing we write is the name of the function, and the name of this function is point, right? Makes sense. That's what it's called. That's what it does. Generally speaking, when you're naming functions, and you will be at a future time, you want to give your function a name that explains what it does. So this one draws a point. It could have maybe been called draw point. That would have been reasonable as well. Maybe that's even clearer, since pointing can mean different things in different contexts. But in the case of P5, it is specifically called just point. So we write the name of the function, and then always after the name of our function, we have information in parentheses. So we write the name, open parenthesis, and then there's a close parenthesis at the end, and then any information that this function needs to do its job is provided inside those parentheses. There are some functions that don't need any information, in which case it is blank, like this. So you just have the function's name and then empty parentheses, because it doesn't need to know anything. Still have to have the parentheses. But the point function, for example, you can't draw a point nowhere, right? You have to tell it where. And so the information inside is the x and y coordinates. So 50 and 50. So we know just from convention that the first 50 means the x coordinate and the second 50 means the y coordinate. So draw a point at position 50, 50. These things here inside the parentheses are called arguments, okay? It's not super, super important to know that they're called arguments. It's just what they're called in programming. You can remember it or not. It's probably not going to change your life too deeply unless you want to get into debates with computer scientists. So 50-50. The other thing to notice, which is sort of natural anyway, is that we separate these arguments, these pieces of information, the x-coordinate and the y-coordinate, with a comma. So we always go first piece of information, comma, second piece of information, and if there were more, we would write more commas to separate them. Okay? I know that I'm dragging this out, but we'll only do this once. So 50-50 is the information that the point function needs. That information is always inside parentheses. And then finally at the end here, you can see I've written a semicolon. Semicolon is the one that's like a colon, except it's a comma. Now, In programming, it is very traditional in most programming languages, but not all, to include a semicolon at the end of an instruction. You could think of it as a way of saying like, go, or please, or oh pretty please, won't you do this for me, or whatever you want. In this class, I want us to always make sure that we remember to include a semicolon after instructions, like this function call. The truth is that JavaScript does not actually require the semicolon. It would still work without it. However, there are a lot of programming languages out there that do require the semicolon, and it is good practice to get into the habit of including it. Okay? So when we issue an instruction like this, a function call, like .5050, we will put the semicolon afterwards. That's the rules, and we're going to stick to them. Okay? So that's some detail, just talking about drawing a single pixel on the screen. But the beauty of this is that this is how we call all functions. We're not always giving them numbers, and they're not all called point, of course, but that basic premise of the name of the function and then information that the function needs inside parentheses, followed by a semicolon, is how it always works, no matter what the function is. And indeed, you can see this is the case here with the background function, right? So we know that this function is called background. It's called that because it fills the background with a color. And we know that the information that it's getting inside the parentheses is these 3 comma-separated values, which represent the red, green, and blue values of the color that it should paint the background. Okay? Exactly the same principle. Name and then information inside parentheses. That's how we call functions. Okay? So this is a very good moment, I think, to go and look at the documentation for P5. Okay? Something that we need to really, really get used to, and you especially need to get used to, is you need to look up how to use things, because you might forget. So for instance, let's go look at the documentation for the point function. We're going to do that by going to Google Chrome, and I'm going to open a new tab, and I'm going to go to p5js.org, which is the homepage for P5, which is this thing that we're using to draw everything. You can see it's got a nice fancy background doing something interesting there. And the key thing that we want to look at here is the reference. Okay, it's listed in that left-hand sidebar. If I click it, it's also got an easy to remember URL right up here, p5js.org/reference. The reference is your friend. This reference is where you can look up literally anything that P5 can do. Okay, so if I'm scrolling down, you can see that there are lots and lots of these things where you have a name and then some parentheses. That means that it's a function. That's one of these things that we can do as an instruction inside P5. And P5 can do a lot, okay? You're not expected to memorize all of these things. That's why the reference is here. Most programmers don't remember everything that is possible to do in programming. They keep the reference for what they're doing open, and they refer to it in order to be able to do their work, okay? So let's go back up to the top. You can see there are some categories here. Let's use that, and let's click on the shape category, because that's where we're going to find point. Click. Here are the shape things that we can do. You can see they're all functions because they have the parentheses after them. And here's the point function, right? So just by looking here, we can see that there are other shapes, and we'll look at those in a second. But if we click on any of these names, we'll get detailed information about how it works. So I just want to look at the one for point, since we already know how it works. So I click it, and the way that the reference works is that the very first thing that you're going to see is an example. So here is an example, and you're going to see a canvas. So this is just like our canvas, right? It's a little one, 100 by 100 pixels. And underneath it, you're going to see the code that is being used to create the image. And in particular here, you can see that there are pixels in 4 locations here, forming a square. And below you can see the instructions that are being used to position those pixels, 0.3020, 0.8520, 0.8575, and 0.3075. Those are the coordinates for these 4 pixels. You can probably work out in your head which pixel is being drawn by which instruction. So the reference always tends to start with an example, so you can get a sense of how something works just by looking at it being used. Okay? And that's what we've just been doing as well. Here's another example with a little bit more complexity. still drawing 2 points, but now they're changing the color and size of these points. And again, each of these things, so now we've run into something new called stroke, which we're going to talk about later, and we're running into something called stroke weight, which you can also look up. All of these new things, if you see something new like this, like stroke or stroke weight, you can go back to the reference and look it up to understand what it does. Okay? So scrolling down, that's a more interesting example. Here's yet another example. This is about making a vector out of points. We won't worry about that. Again, investigate if you're interested. If we get past the examples, we then get a description, hopefully roughly speaking in nice understandable English, that tells you what it does. Draws a point, that's kind of right, that's kind of the whole thing. It gives you some extra information like changing color and changing size, for instance, which could be nice depending on what you're trying to do. The thing I really want to draw your attention to here is this little syntax section, okay? Which is kind of coming at the end, right? Here you can see the function is being explained again or shown to you again, but in quite a different way that's worth just pausing over. Okay, you can see that it says point, which is the name of the function again, and you can see that it still has parentheses surrounding the information that this needs. These are the pieces of information that it would need, but now instead of numbers, you can see that it's using symbols to explain what information is needed. So here it's saying that point needs an x, a y, and then it's got a z or a z inside square brackets, okay? Now we know these first two, the x coordinate and the y coordinate for where to draw the point. If you've done any 3D math or 3D graphics or anything, you probably know that this extra z thing is about the third dimension, the depth dimension that goes along with the vertical and the horizontal. Just very important to explain, these square brackets around the z, they're telling you that it's optional. You don't have to provide that third number when you draw a point, okay? You can just draw a point with just the x and the y. The z is optional, and you would only use it if you were doing things in 3 dimensions. Okay? That's how syntax explanations work in the reference. It gives you the name, and then when it lists those pieces of information, it writes them as symbols like x and y. And if you see square brackets around them, it means that they are optional. You can see explanations down here that tell you what each of those symbols mean. Notice how they're called parameters here. When we are putting a real number in, it's called an argument. So when we say point 50, 50, and to actually draw a point, those two 50s are arguments that we give to the function. When we're talking about what the function takes more in the abstract, like it takes an x coordinate and a y coordinate, then we call those things parameters. This arguments versus parameters thing, again, it's like something that computer scientists care about. You can choose to ignore it if you wish. Here you can see that it's explaining that that x, it was referring to the x coordinate, and you can see that it's telling you it should be a number, like 50 or 500 or 5.1. And the y is the y coordinate, same thing. And then here we have z as the z coordinate, and you can see here again it tells you that is optional. You don't have to provide a z, but you do have to provide the other two. Okay? That's the entire documentation page for point. So you will see at the very top the name. You'll see some examples of it being used in the real world, so to speak. You'll see a description that explains it in hopefully plain English, and then you'll see examples of the syntax of how you write it, where it talks about what each of those numbers that you would give it actually mean in terms of x, y, and z in this instance. But it will depend on the function that you're actually reading the documentation for. Okay, so that's quite a decent side road into the documentation, but looking at this reference is a really important way to make sure that you know what you're doing. I will also just very quickly point out that if you were to just browse through all of this stuff, even just the 2D primitives, you can see that there are triangles and quads and lines, oh my. There are curves. You can see that there are 3D things that we can do, so now you know that P5 can do stuff in 3D, which is exciting. If you just browse through this, you'll get this sort of sense of what's possible in P5 these days, which I think is worth doing. It's worth giving it a read just to get a sense of what's available. It might stimulate your imagination. Okay, so that was quite a bit for us to cover. Let's return to our code now. So we've got our point at 50-50. We've got our background, which is being set to this gray color. The next thing that I just wanted to point out, let's go back to our actual code. this is very small, isn't it? This canvas is small. We don't really want to spend the entire semester working in a 100 by 100 pixel canvas. So let's learn the instruction for changing the size of the canvas. And that is a function called CreateCanvas. Now, CreateCanvas, we always put it at the start of setup. It's the first thing that we're going to do if we're going to do it. If we want a custom-sized canvas, put it at the start. That's because the canvas has to exist before we can do literally anything else, like drawing or painting things, colors, or whatever. So CreateCanvas always goes at the start, but currently I've got empty parentheses, and that's probably not going to be very helpful, given that I said I wanted to change the size of the canvas. So you could pause if you want and rack your brain for what information I might give it. And now you're back, and you're excited to know if you got it right. As you probably would have imagined, the information that we give it is the dimensions of the canvas. First the width and then the height. So this here is asking for a canvas of size 500 pixels by 500 pixels, right? And if I save that and I go back to my browser, the canvas, which is this gray area, has now expanded to be 500 by 500 pixels, right? You can see that my pixel that I drew that was in the center of the old canvas at 50/50 is now in the top left corner because the canvas is that much bigger. If I wanted my pixel to still be in the center of the canvas, now I'm going to have to change this to 250, 250, because that's halfway on both axes of my new canvas size, right? So 250, 250, I save, and when I go back, there is my pixel just above the cursor there, right back in the center. Okay, there we go. So now we've got a nice little program that does something. It creates a canvas of dimensions 500 by 500. It paints it a color, which we'll talk about more soon, and then it draws a point in the center of that canvas at 250, 250. Okay. One thing that I would like to just point out now, even though we don't have, we don't have a ton of stuff in our program, but it is a program nonetheless. It's really important when you're learning to program to feel the freedom to play around, okay? Now you can't play around with just anything right now because programs break quite easily. But you can see that we've got all of these numbers, right? 500, 500, 200, 200, 200, 250, 250. I encourage you to play around with these numbers and see what happens. So for instance, if I change it to CreateCanvas 500, 1 and save that, and I go back and look, now we can see that the canvas is just a line because it's only 1 pixel high at this point and 500 pixels wide. So it looks like a line. I could change the background numbers. I could just type in random stuff and see what happens. There we go. 1, 2, 3, 38, and 1. Let's see what happens now. Obviously, we think it's going to change color. It's changed to quite a dark red. Let me change this to be 255. 138. Maybe that'll be a bit more interesting. So I'll save that. And now it's kind of orangey. So you can play around with those numbers and discover colors that way. We'll talk more about colors later on. And likewise, I could draw my special point wherever I want. Because I've changed the canvas size to 500 by 1, this point at 250, 250 is again not on the canvas anymore, right? It's off the bottom of the canvas, which is only 1 pixel high. If I want my point to still be on the canvas, I have to change its y-coordinate to still be within this canvas. You might think that you would change it to 1, but remember that the very top pixel, which is the only pixel in the vertical axis on this canvas, is numbered from 0. So you would actually say 0.250 and then 0. It might be a little hard to see, but my cursor is just under it right now. There's a little black dot on my canvas here. That's where the pixel is now being drawn. Okay, wonderful. So I'm just going to revert some of this stuff so that it's less tiny and weird. Back to my nice square, except now it's an orange square with a dot in the middle. Perfect. Now, in a sense, you know what you need to know for just about everything. In particular, now you know how to read the documentation. You could always go back to the reference in your browser. It's always worth having it open. You could scroll to the top and then go to the shape category. And then you could play around with all of this stuff because you can just read what it is. I suggest that for now, it's probably worth just playing around with the 2D primitives. That's what I'm expecting you to know moving forwards just for the moment. You can play with the other stuff too if you want to. Don't hold back if you're interested. But each of these different shapes is now it's explained, and you can get their explanations. So for instance, if we look at rectangle, we can see that we draw a rectangle by writing the word rect, and then inside the parentheses there are now 4 numbers. You could probably guess what the 4 numbers are both by looking at this square that it's drawing and just by thinking about how you might specify a rectangle. But generally, as a programmer, the thing you're going to want to do is read the syntax description below, right? So I would end up, generally speaking, you might look at this stuff, look at this cool beveled edges stuff, that's pretty fun. So that might be worth thinking about, pretty entertaining. But I would usually scroll down to the description and the syntax, right? So description draws a rectangle on the canvas. A rectangle is a 4-sided closed shape with every angle at 90 degrees, if you want to do the geometry of it. But importantly, my eye is always drawn to the syntax listing, okay? And the explanation of what the pieces of it mean. So we can see that there's a couple of different ways to draw the rectangle. There is an option here where we can specify the X, the Y, and the W, whatever the W is. You can probably guess what the W is, and you can also look it up down here in the parameters. W stands for the width of the rectangle. So X, Y, and width. And then the rest of these are optional. So H, which you probably guess is for height. If you don't specify the height, you're just going to get a square. It's going to use the width for both. So you can say X, Y location, width, and the height. And then there's this other stuff here. And these are radiuses of the corners so that you can do that beveling. I personally almost never use these last 4 parameters. You can if you want to. Could draw some nice beveled rectangles. I tend to use these 4, X, Y, width, height. One important thing that is not explained here is where on the rectangle this X and Y are, right? Because it could be the top left corner, could be the bottom right corner, could be one side, could be the center. And you actually need to read in the description to know that. Here we go. By default, the first 2 parameters set the location of the upper left corner, okay? So when we're drawing rectangles, they're being drawn from the upper left corner. That's quite a bit of information, but again, you know, this is how we learn programming. We have to learn to get used to the different pieces of programming. So let's draw a rectangle now that we know how it works. So let's go over here. After my point, and I'm leaving gaps between these just so that you can maybe see a bit more easily. I know that I write the name of the function, rect. I open parentheses. You can see that because I've got prettier atom installed, it auto-completes. I think it's either, it might actually just be atom, auto-completes the brackets for me, so it's got the closing one there for me already. It's meant to be helpful. I need to give a position. I'm going to draw this rectangle with its top left corner. Remember the X and the Y specify its top left corner by default at 0, 0, so the top left corner of my canvas. And then I'm going to specify a width and height of 250 and 250. So that means that it's going to be 250 pixels wide and 250 pixels high. And remember your semicolons, right? So draw a rectangle. Top left corner of the rectangle is going to be at 0, 0. That's the top left corner of the canvas. And its height, width and height are going to be 250 pixels. So if I save that and I go over to my browser and back to the tab that has my project, there is my rectangle. And you can see that it has some default colors, right? You can see that it's filled in with white. We can tell it's filled in with white because it's going on top of the orange of the background. And you can see, if you look a little bit closely, that it's outlined with a 1 pixel wide black line. And as we said, you can see that its bottom right corner is reaching to the middle of our canvas because we made it 250 by 250. Great, so that's how you draw a rectangle. There's nothing more to it than that, and it's the same premise, right? Name of function and then the information it needs. If we were to say, let's make it less wide, I'll make it 100 pixels, but I'll make its height 500 pixels, so the corner stays in the same place, but now it's 100 wide, but it's as tall as the entire canvas, 500 pixels. Save that, I go back, and now the rectangle has changed shape to extend all the way to the bottom, and it's 100 pixels wide into the canvas. Okay, that's literally how it works. So I'm going to undo that, and I'm going to go back to my 0, 0, 250, 250 thing. Perfect. And now the truth of the matter is you can learn all of the other things yourself. There's one called line. To draw a line, you've got to imagine what does a line need to know. I can just tell you. You could look it up in the reference again, of course. It wants the first point, the start of the line. If I start it at 0, 0, for example, it's going to start at the top left corner of my screen. And then it needs the end point where the line gets drawn to from there. I'm going to draw it at 500, 500, which is the bottom right corner of my screen. So it should be a diagonal line from the top left to the bottom right. If I go back to my browser, there it is. Looks like a kite or something now. So the line started at 0, 0, which is up here, and it gets drawn all the way to 500, 500, which is here. If I wanted to draw a line crossing in the opposite direction, what would I do? You could pause and think about it. I'd want to draw a line again, so I'd write line. But how do I specify, say, the top right corner of my screen? Well, I know that if it's all the way to the right on the x-axis, it's going to be at 500, because that's all the way across the canvas. I want it to be at the top, and I know that the top under y and my y-axis is 0, so it's going to start at 500 and then 0. And then the destination is going to be the bottom left, so its x is going to be all the way to the left on the x-axis, that's at 0. And its y is going to be all the way to the bottom of the canvas, which we know is 500. So that's the line that's drawn from the top right, which is 500, 0, to the bottom left, which is 0, 500. Go back, and now we've got lines crossing in both directions, and we're starting to make a beautiful artwork, aren't we? Just say yes. There are many more of these. I'll just do one more, which is an ellipse. An ellipse is, as we know, a kind of oval shape with a width and height. That's what we maybe know from geometry at least. We write its name, and then its information, which is where we want to draw the ellipse, its x and its y. I'll just write those numbers, those things in here. Its x and its y, and its width and its height, right? That's what we would see in the syntax specification. So the thing to know about an ellipse, and this is in the documentation, is that by default, an ellipse is always drawn from its center, rather than its top left corner, okay? So the x and y are going to be the center of the ellipse. I'm going to position them at the center of my canvas. So 250, 250 for the x and the y. And for the width, I'm going to specify, I don't know what I'm going to specify, 100 maybe. And for the height, I'm going to make it 100 as well, because I think that ovals are hideously ugly in most circumstances, and circles are beautiful. So it's an ellipse with its center at 250, 250, which we know is the center of the canvas, because that has a width of 500 and a height of 500. And it's 100 by 100 pixels, which will make it circular. So we go back and look at our web browser after saving, and there is our circle. Notice that it has the same properties of color as the square, right? It's filled with white, and it's got a black outline. So one thing that we can tell right now from this that's important to remember is that the order that we're putting these instructions in matters, right? You can see that, well, the point that we drew early on, which was in the center of the canvas, we can't see it now because it's behind other things. We drew the point, and then we drew the rectangle, and then we drew the lines, and then we drew the ellipse. And you can see that that's the order that they get put down, right? So the point is invisible, it's behind the circle. The rectangle was next, and that's behind the line that crosses over it, and it's behind the ellipse. And then the other line is also behind the ellipse, and so because the ellipse was drawn last, it's on top of everything. It's just like Photoshop layers or something like that, right? It's the same order that we wrote it in. So the point is right at the back because we drew it first. The ellipse is right at the front because we drew it last. We can experiment with that by changing the order. If we want the ellipse, for example, to be behind the rectangle, we could put it there. I just cut and paste the ellipse line, right? So now the ellipse line is here, and it's because it comes before the rectangle, it's going to be behind the rectangle. If we go back, we can see now the ellipse is behind the rectangle, and it's behind both lines. And now it looks like a kite again, even a little more, which is lovely. Great. So what a beautiful drawing this has turned out to be. Okay. So you can look up the documentation for all of the other shapes. It's not, it really isn't rocket science. Honestly, if you look at the examples, read the description, and then look at the syntax description, you'll be able to use all of them in no time. The other thing that I just want to cover before we finish up is this idea of drawing modes. Okay, there are different ways to draw shapes, and it kind of depends on what you are trying to accomplish, right? So I'll just delete all of my stuff except for the background now. You can do the same if you want. By default, as we know, to draw a rectangle, we draw it from its top left corner. So if I draw a rectangle at the center of the canvas, 250, 250, and let's say that it's 100 by 100 pixels, like that, and I save, so it's going to be drawn at the center and be 100 by 100. If I go back, you can see that it's the top left corner of that rectangle that's at the center, right? Which is fine, that's just how it draws, but that's the default behavior. If I wanted to draw this rectangle exactly in the center of my canvas, that's going to be very slightly challenging. It's going to involve doing a bit of math, right? Because I know that I don't want to draw its top left corner at 250, 250. I actually need to draw it with a kind of an offset, right? So I know that the center is 250, 250. I know that the rectangle is 100 by 100. So I actually need to draw the rectangle at 200, 200 to account for the shape of the rectangle and the fact that it's being drawn from its top left corner. That's just some maths, right? So now it's in the center if we look in the browser, but that was kind of annoying. That's not a great way to draw something in the center like that. Fortunately, should we need to draw things based on the center, rectangles based on their center, we can use another function which is called rect mode. And this is, of course, is in the reference as well. So we say rect mode, and we can change the rect mode. So normally the rect mode is set to something called corner. This is the default. It means that it will be drawn from its top left corner. But I can change that to the word center, written in the American style, the US style. And that means when I put this in, it's like setting something again in Photoshop. It applies to everything that I do afterwards. So once I've written rect mode center, that's going to apply to every rectangle that I draw after here. So now I want to draw my rectangle in the very center of the screen, so I change its position to 250, 250, because it's going to be drawn from its center. The X and the Y refer to the center of the rectangle. If I go back, now it's in the center, but in a much more sensible way, right? Because it's being drawn based on the middle of the rectangle. And that makes it easy to do things like, I don't know, concentric rectangles, right? I could draw another one also at 250, 250, but it's a bit smaller. So let's say it's 80 by 80. The rect mode center still applies, right? It's just, this is in force until I change it again. So now I've got two rectangles, both being drawn from their centers. So I get these inset rectangles. And I could keep doing that if I wanted to. This is a much, much easier way of drawing these concentric rectangles, right? It's easy to do because they all are positioned in the same place, which is the center of the canvas. This would be much harder with the corner mode. There are other modes. You can look those up. There is exactly the same thing for ellipses. So let's replace this and let's work with ellipses. So if I draw ellipses, we know that by default they're positioned at 250, 250. And I'll do the same thing, 100, 100. This ellipse will be centered by default because the ellipses are drawn from their center. And I could draw some more ellipses to create concentric ellipses, just like I did with the rectangles just now, 60 by 60. Okay. Oh, what did I do? Oh, this is interesting. I mean, I'm not looking to create bugs here, but if you look at this line, can you see what mistake I've made? You could pause it if you're interested. I have a dot here instead of a comma, and that broke my entire program. That's kind of a perfect illustration of how fussy programming is. It has to be a comma or it won't work. So I saved it. Now I've got my three concentric circles. So that's the default. If I wanted to, there is a corresponding command called ellipse mode, which I can use to change how the ellipses are being drawn. And I could change it to be more like the way that rectangles are drawn based on its corner. And if I save that, then I get kind of an interesting shape, right? Each one is being drawn as if it has a corner here in the center, and they're being drawn to their different sizes. So this one's the 100 by 100 one, 80 by 80, 60 by 60, and you get kind of a nice, almost three-dimensional looking cone shape. Wonderful. That is what I wanted to show you, okay? Because I'm going to become obsessed with this, otherwise I'm going to make my little cone shape, so I'm just going to keep diminishing the dimensions by 20 each time, like that. So it's fun to play around with drawing. Now I've got a kind of fake cone. You can imagine that that's a 3D object. The key now for you is to play around with this, right? We'll have an activity where we can play around with it, but just draw shapes and see what kinds of effects you can get. And in particular, please go to the reference, which is here. I'll go back. And especially, read these 2D primitives and have a play around with them. Just see what you can accomplish. It is pretty fun telling your computer to draw stuff, and it's a great way to practice just getting used to this idea of issuing instructions to your computer like this. Okay, that's the end of this video. I'm proud of you for sticking with me and for tolerating my video production skills, which are probably ever so slightly not that amazing. Here is my face just for you. I will see you in the next video, well, I guess you'll see me in the next video. I can't see you at all, but I will see you around, no doubt. Okay, bye.